And remember, we are talking about a water gate or floodgate here, and we first consider one piece here, one slice here, because for this slice and we have for this slice we have force going this way, right? And then we have the total force equal to what? Total force is, there is a total force of this one. Total force of this one acting on this part of the water gate. But because the pivot is at C prime, so we have a force. We have a force and we have a moment arm here. Moment arm is Y. So we have the moment of a slice about line C and C prime is equal to this one. And if we have this, and because this gamma is not a function of y, so it can be taken out of the integral, and we have this one. And this is the definition of what we call moment of inertia or second moment of area. The biggest thing you need to notice is if I ask you for Ix, that is about x-axis, the second moment of area about x-axis. Remember, inside the integral, we have y squared here. It's okay. If I'm asking in the examination for Iy, you need to put x squared here. It's okay. Now, and so we have now we have here we have an example of doing this, and for this rectangle, and we have for the Ix prime about x prime axis, we have the Ix prime is equal to bh cubed over 12, and that's the first. The first thing is the units of I is equal to the length to the power 4. Okay, length to the power 4. The second thing is you will see this. I think you can remember this after you take your year 2 course, and you will see this next year. Okay. Now before we begin our sample problem 9.3, I did sample problem 5.4, and it is easy to get x bar right, and I think you can do this. And for y bar, you don't need to do this. You don't need to do this area for y bar, because we can using the same thing way to cut the area, and we can get the centroid of the whole area by the centroid of each part. And of course, for one slice here, and we can get the centroid of this slice because this is at the middle of the height. Okay, so we can get y bar there. Now let's go to problem 9.38, and here, and determine the moment of inertia. That is moment of inertia is I, with respect to and in many in your future textbook, and it will be written simply as WRT. Each of the coordinate axes. It's okay. And here we only do it in one way. We want to do it only in one way. That's we cut this one. Now, in mathematics, it means we are determining Ix and Iy. Okay. So for Ix, so what are we calculating? How do we get Ix? So if we get Ix, what should we write here? X or Y? Y, okay? So let's do Iy first. So therefore, each stripe we get this one, dA, and the distance between dA and the y-axis is x, right? And for this curve, k is equal to b over a squared. This is problem 5.4. And therefore, we have x squared, and then we have dA is equal to, and the width of this slice is dx, right? So we have dA is equal to y dx. Let me write it here, right? Y dx, and of course dx is here, and what is y? Y is equal to kx squared. So we have b over a squared x squared, and this is y. Okay. And for this one, we have because we are not integrating from minus infinity to plus infinity, so we should have something. We are only doing it for a range of x only. We are only doing that integral for a range only, so it is a definite integral. Now, so what's the range of the definite integral from x equal to what to x equal to what? From x equal to 0 to x equal to a. Therefore, we have from here we have p over a squared x to the power 4 dx. And this is our answer for IY. I think you know how to do that part, right? Now, after getting our results, for example, if you get these results in the examination, what should you do next? You check the results. How do we check the results? We look at the units of the. We look at the units of this answer. So what's the units of this answer? Now that is linked to the power 1, 2, 3, 4, 5, 6. Which one? 4. Okay, because A is a link. B is also a link. So link to the power 3 times link is linked to the power 4. So it is at least we are doing we have the correct unit. Some of your seniors did not do this, and it should be, and they don't, so they are wrong. Okay. Now that is for IY. The next thing we want to do is IX. Of course, if we go for the definition, it is equal to y squared dA, then we need to cut in this direction, but we don't want to do this. I don't want to do this either. So, and what we do is we consider the moment of inertia of this slice, dIx. We consider the moment of inertia of this slice. And then we add the dIx from this slice, and then we calculate the dIx from this slice and this slice and this slice and so on. And then we add all of them together. So there is another thing. For this if we calculate the moment of inertia about x-axis, can we get the same results by moving this slice to here? It seems we can, because for calculating this dIx, that we are calculating the distance between each slice here and the y here. So we can, if you think it is better to do it here, that you can move it to the center. Now we go to let's do this dIx here. For dIx, it is equal to what here? We calculate this one, and this one is called, let's say, dA2, and this small area has the distance of y with the x-axis. It's okay. We are calculating this the moments of inertia of this slice, of one slice here, and for one slice here that because Ix is equal to y squared dA, so we are taking about we take one slice with distance y to x-axis, and then we do the integration for this one, this one, this one, and this one, and this one, this one, to get the moment of inertia of this slice. It's okay. Now, so we have this one. We have y squared dA2, which is equal to y squared dx dy. This one is the height of this slice is dy, and the width of this slice is dx. So this is dA here, dA2 here. The last thing we need to consider is this is also a definite integral, like this one. So what should we fill in here? So this is we are doing integration on the y direction. So we are taking from y equal to 0 to the height of this slice, right? Because we are taking the moment of inertia from here. We are taking from y equal to 0 to y equal to some y here. Is that right? Now here we have y equal to 0, and what's the height of this slice? The height of this slice is actually equal to the original function. Or should I write y2 here? The height here is y2. So it is actually equals to this one. So it is equal to 1/3 of this one. Something like this. Now, is it correct? At least we can check the units of the, because this is we have a to the power 6, x to the power 6, and b to the power 3, and then dx here, and sometimes we don't know whether we do it correctly, right? So what should we do here? Now that is the length of power 3, and then that's the length of power 6. So, and there's the length of power 1. So 3 plus 6 plus 1 is x length to the power 10 here. And then here in the denominator, we have length to the power 6. So what is the total unit of this answer? It is the length to the power 4. Okay? So at least we are doing, it should be okay. Now, so for the last step that we get, we calculate Ix. Ix is equal to Ix is equal to Dix. So it is equal to B cubed over B. Oh, sorry. This is from 0 to A. Sorry, that I should. Then it is equal to this one.